Yeah, thank you very much for inviting me to East Shanghai. My name is Makoto, and I work at ENS, ECM Name Service. And I actually went to Shanghai back in 2016 at DevCon Shanghai, and that was my first kind of big Ethereum events, and it was a very interesting moment. And that was the first time I went to kind of mainland China. I've been to like Shanghai, Hong Kong before, but Shanghai was first time, so it's mind blowing all the development. But that was almost 6-7 years ago, so I'm sure that Shanghai has even progressed more. And I'm very excited to present what we'll be up to as a ENS. And so today I'm going to specifically, so ENS can do a lot of stuff, but I specifically want to talk about so-called subname, which is a bit, in my opinion, it's being underutilized, but we've made some progresses. So I'd like to introduce like three, basically first I'm going to talk about what ENS and the ENS subnames are. And then even though I say subname, there's a kind of different ways to basically issue subnames, and there's some pros and cons. So like I'm just gonna describe as first three different subname types, like NFT subnames, digital twin subnames, and then gasless subnames. And I'm just gonna introduce all of them. So it's up to you, depending on your community needs, which one you would like to use. Okay. So what is ENS subnames? And before going to subnames, what is ENS? And so I'm hoping that most people know what ENS name is, but the primary function of ENS is to basically turn this kind of long, human-unfriendly ECM address, which usually consists of like hexadecimal. Well, it consists of hexadecimal. So this is my ECM address, which starts 0x58384, to my ENS name, which is matokun.is. So like if you go to MetaMask and if you type matokun.is, you can look up my ECM address. But I also have another one, makoto.argentxyz, and the Argent is one of the pioneer of the wallet. I think nowadays people start hearing something like account abstraction to instead of using kind of EOA, externally owned account, which is tied into your public key private key pair, which is hard to manage. They actually introduce a smart contract as a wallet, and that allows you to be more flexible to manage so such as like social recovery, that kind of stuff. And I think they launched somewhere like 2018-19. I don't know exactly when, but one of the pioneering things they did back then is that they basically, as part of creating a wallet, first thing is I think first harder is it's hard. You have to write down seed phrases and stuff, and Argent doesn't have to. You don't have to do that because it's a contract wallet. But second thing is, when you first create a wallet, you don't have anything, so you have to transfer ETH from some other exchange, or you even have to ask friends to send small amount. But like again, showing that wallet address is very challenging. Then what they did is they allow you to create your own username as subname, Makoto Argent XYZ. So from the moment they basically user on board, they already know like how they had like ENS name built in. That was kind of amazing thing back then. So just to recap, what subnames provides is for example, matokun.is. Probably if you have that name, you may have went to app.ens.domains, and you have to pay registration fee, and the registration fee is necessary to prevent people from squatting. But once you own the name, for example, matokun.is, issuing subnames is solely based on the parent, which is Matokun. So because I already have a power, ENS itself as a protocol doesn't have to charge registration fees, hence no registration fee. And as long as you can basically have the name, you can issue subnames. So you don't necessarily have to keep registering new .is name for every time you have like new wallet or something. One of the use case could be like, I could create a subname for each wallet I use, such as metamask.is or like I don't know, trust wallet .metamask.is, that kind of stuff. And anyone can issue. And as I said, that's a great way to onboard new users. But it came with oops, sorry, I think I went too fast. Yeah, hierarchical structure that parents can always overtake. The part of the reason of NFT to be the kind of token is that it's transferable, right? And if parents can overtake children all the time, it kind of defeats the purpose for that. That's part of the reason that like you can make it, you can kind of write a code to make subname NFT by yourself, but there's always a risk that parent can overwrite. And also at the same time, names expires, and whenever it expires, the subname also expires. So there's some consequences. To overcome that problems, we've been working on something called name wrapper for almost like probably 3 years. And it only went live last March. And what it enables is like, as name suggests, it wraps the name. So like both .is name and also, .is name is actually ERC721 NFT, but name wrapper is another set of NFT. It's 1155, I think. Yeah, and what it does is you wrap the name, and by wrapping it, so ownership moves to the name wrapper. And name wrapper has certain kind of utility or access control to to kind of restrict some of the features the name owner can have. And a couple of the main things is first, I mentioned that to make it as an NFT, it's important that the subname itself has its own control without being overwritten by parents. And there are some, we call it fuses, that you can ban. And once you ban, you can basically restrict the power. And the first thing you need to do to anything is you have to control the parent's ability to basically control the subname. So these are one of the fuses. And then once that's been banned, then all the subnames you create, you can actually kind of fine-tune the to the ways to basically the subnames can behave. And based on, so there's lots of variants, but by combining multiple kind of access control, you can create kind of unique subnames, such as like if you ban like can extend expiry and the parent cannot control, it allows you to sell as permanent names because parent cannot run for the children. And also in addition to this can extend the parent cannot control, if you say cannot unwrap and cannot create subdomains, you could sell subnames but prevents from creating their own subnames. So you can kind of make the limited edition and that kind of stuff. So, and there's a couple lists you can do. So it's kind of up to your imagination that by using different combination of the fuses, you can have different ways of controlling subnames. And in fact, I didn't mention the name, but I think some of our community members, it is difficult. And so first, one of our team members created kind of intellectual tool sets called Fusebook, which allows you to kind of play with burning a couple of fuses, and if it burns, what allows you to further burn what kind of cascaded impact and all that stuff. So this is kind of first things to help you understand more. And I didn't mention in this slide but I think our community member Prem, he created something called unruggable names, because like setting all these things, even though it doesn't require any technical skill to set these fuses, because if you go to app ENS names, you can actually pick these things. But actually, if you want to issue like 100 names, and if you try that all yourself, it will be confusing and hard. So I think community member created some product around something called unruggable name to make it easier for you to create these names. So that's a partial variant of so-called subnames. And second variant, I kind of coined the term, but I call it digital twins. And so problem in this scenario is it's kind of specific use case that we received a couple requests to say, we already have kind of ENS collection, the NFT collections, and we want to kind of assign subnames attached to that NFT ownership. So ownership of subdomain follows ownership of the NFT, which you can usually create kind of subdomain registrar to only allow people of the owner to claim that subname. That can be done by kind of creating a registrar. But what it doesn't necessarily do is that if this NFT ownership changes, the ownership of subname automatically change. That you couldn't do it by yourself. And let me just change this. Then that's one solution to help solve this problem is ENS IP10, so-called wildcard. And this is mostly done on the kind of client level, is that it's a convention that if you look into basically doodle.is or something, and if, sorry, like foo.doodle1.doodle.is, and if that subname doesn't exist on ENS registry, it asks to its parent, basically doodle.is, to say, do you know how to resolve these subnames? And at this point, you can write a custom logic in a resolver of the parents to say how to define subnames. And in this case, you could actually, the resolver of the parents, doodle.s, can write a logic to say, if you are the owner of Doodle NFT token ID 1, you would own 1.doodle.s. By doing that, it dynamically tracks basically the ownership of the subname, tracks the parents. That's why I call it digital twin. And we knew that, and also another benefit is because it's kind of automatically generated, you don't necessarily have to create, it can be gasless. And we knew that in theory you could do it, but we never had a chance to actually make it work. But one of the great thing about ENS community that there's always talented developer who's trying to tackle interesting challenges. And Rafi.is, who is actually known for contributing a lot into the ENS even protocol, created something called what it's called, NFT owner.is, and he kind of created a kind of factory to allow you to start creating a subname for multiple different NFT collections. So even though this is experimental, I think it's already on mainnet as well. So you can play around and see how it looks like. Okay, and the last piece I want to focus on is so-called gasless subnames. And the part of the reason so Argent stopped doing is that, and actually it's not just Argent, I think there's a couple big companies used to issue subnames for their users, but most of them stopped because gas became very, very expensive back in 2020 during the DeFi summer, and the following JPEG summer 2021. People still register .is name, which was great, but yeah, projects stopped issuing subdomain for free because it didn't pay off. And so to solve that, we have another kind of specification called EIP 3668, secure off-chain data retrieval. We also call it CCIP read. Is you use a combination with the wildcard specification. In the wildcard specification in SIP10, you ask subname, for example, foo.matoken.is, does it exist? And if it doesn't exist, client library look up to the resolver of the parents, matoken.is, to say, hey, does it foo.matoken.it exist? In the case of digital twin, you look up the information in the same chain, right? The NFT of the Doodle NFT was on the same Ethereum chain. But what this specification allows is to retrieve the data from off-chain using so-called gateway service. A gateway service is just web services, which you can just write in any programming language. And this intuition is, if I try to explain it to someone who's not technical, it's almost like getting back to the roots of kind of how NFT works, is that in ENS, so far, everything was on chain, like including your Ethereum address or like avatar text record. But that was kind of designed back in 2016, 17, when gas wasn't too expensive. But like, I think NFT itself, you probably know that NFT ownership is on chain, but their metadata, especially like in JPEGs, are not on chain. You have something called token URI, and token URL just points to some endpoint URL, and the URL is in charge of returning it. So if it's in IPFS, it could be in IPFS or someone else's database, right? So that was external web services returning it. So that's kind of the gateway on our architecture is similar to the token URI, and that can be anywhere. And so couple of examples, it's already, so this, I think, protocol itself was kind of standardized a couple of years ago, and there's already a couple of big ones already in use. Excuse me. And cb.id by Coinbase, if you install their Chrome extension, you can create their profile, and as part of the profile, you can get their username, and that username becomes subname under cb.id. And then when you update their profile on their extension, which doesn't cost any gas, it also actually reflects on our ENS manager, so that you can basically, what their profile information on their database is proxied through on ENS. So and another example is Lens. So Lens is known that it's a kind of social network on Polygon, and Polygon is not layer 1, but basically they integrate it so that if you type, for example, Stani let's say founder like Lens and Abe Stani have the profile called Stani.lens. If you go to MetaMask and Stani.lens.xyz, it proxies to .lens address. So this can be done whether it's in like database or it's in other chain, or I think there's someone created an example on Google Spreadsheet. So like if you change your text record on Google Spreadsheet, it automatically reflects on your ENS names. And this can be done, in subnames. And there's interesting distinguish is that I mentioned the NFT metadata analogy. That NFT metadata is not kind of immutable or trustless. That if someone changes the NFT token URI is usually just a URI. So the server which return the information of metadata, they can just change the information, which is same for this off-chain, this gateway, which I explained so far. But using the same standard of CCIP read, you can also create something called L2 resolver. And the difference is that on L2, some people may have a different definitions, but in my case, I define L2 is basically rollup, such as optimism rollup, Arbitrum, optimism, and the ZK rollup, such as like StarkNet, ZK Sync. I think Polygon has a new ZK EVM coming. So all these chains, one thing unique about these rollups is that they secure their security to L1 by periodically basically committing their state root, which means like hash of their entire L2 world into L1 periodically. So if something happens on L2, people can exit into L1. So that's what make it kind of L2 as part of Ethereum L1 ecosystem. And we are building, and we already have built some of the prototype which uses this specific character of the fact that layer 2 securing the security into L1 by basically gateway. When you gateway returns the data, not just returning the data, you can actually fetch the proof. It's called I think storage, but there's a state root and there's a storage proof in the L2, and you can actually verify that if the L2 data is actually on the L2 within L1. So by using this mechanism, we call it trust minimized gateway. The gateway can still, so in the off-chain, the old example I mentioned so far, if this middleman or gateway service get compromised, they can return wrong data. So the security of gateway is very critical. I think it's okay for someone like centralized exchange to provide this service because they have a same security assumption that they are the guardian or they are custodying their customers' assets. So it's kind of same security model. If they get attacked, there's a risk of the address being changed. But in this case, even attacker attack the gateway service, they can stop responding so that you can't get the data. But if they fake the data, L1 still has a way to verify this data whether actually exists on the L2 or not. So we call it trust minimization. And currently, we don't have anything on production yet, but we have prototype on Optimism Arbitrum, and actually it's on the StarkNet as well. And also linear chain, which is I think built by consensus. So these proof of concept, Optimism Arbitrum, ENS Labs created. StarkNet is built by Nethermind team with our grants. Linear team's case, they just read our reference implementation and they created by themselves, and they have a testnet version on their testnet. So if you are interested, if there's something I can share the link later, but you can try. And I think they are kind of giving away kind of testnet name right now. So you can actually try to see how it looks like to play with each getting subname in kind of trust minimized but gas cheap way. And also lastly, I mentioned, so if you want to play with L2, then going to linear one is probably the best way. If you want to also build this kind of off-chain way, there's a company called Namestone, which is trying to make it commercializing as a service, so like it's much easier for your community to issue subnames with gasless. And also we have our team member Greg. He built a demo pack for ENS off-chain registrar, which allows you to actually basically register name just by signing signature, and that data is stored in a kind of key value store. So again, there's a link. I think it has a GitHub link, but you can actually try it out. I think this is it. Yeah, so this is 3 different ways to issue subdomains to your community, and I hope you enjoy my talk. Thank you very much.
Thank you very much, Makoto. Thank you again for being with us. So personally, I'm also myself looking forward that ENS will be like our home address in a digital space, just like we live in the real world. Okay? So we are heading there. So yeah, keep building. Thank you again for sharing. Feel free to disconnect from the meeting.
Thank you.
Thank you. Bye.